Thermal engineering is an important subject for mechanical engineering aspirants for GATE exam as well as engineering services examination. So here I am providing a syllabus of thermodynamics and its applications for GATE examination. This is the total syllabus of thermodynamics and its applications called as thermal engineering. Very important and high weightage is coming in GATE examination. First topic is thermodynamic systems and processes. So very important, what is system, what is surroundings, what are the different types of systems like closed, open and isolated systems. So very important. Second topic is properties of pure substances. So there are two different type of properties are there. One is extensive property, another is intensive property. Extensive properties depends on mass. So some of the extensive properties are mass, volume, internal energy, enthalpy, entropy, Gibbs free energy, heat capacity. Intensive properties does not depend on mass. So examples: temperature, pressure, density, specific volume, melting point, boiling point, specific heat capacity, refractive index. Next topic is behavior of ideal and real gases. So ideal gas means which follows ideal gas law, that is PV equals to nRT, so which gives 100% efficiency. But a real gas that exists in nature, so no gas is truly ideal in the nature. Zeroth law of thermodynamics, which states that if two systems are in thermal equilibrium with a third system, then they are in thermal equilibrium with each other. We can see the figure and we can understand if three systems are there, each system mutually thermal equilibrium with other system. First law of thermodynamics states that energy can be converted from one form to another, but it cannot be created or destroyed. The calculation of work and heat in various processes based on delta U equals to Q plus W. Delta U is change in, Q is heat transfer, W is net work done. Second law of thermodynamics. In second law of thermodynamics, there are two statements: Clausius statement and Kelvin-Planck statement. These are very important. Some of the examples and applications of second law of thermodynamics we can observe in melting ice cube, mixing of gases, heat transfer processes. Next topic is thermodynamic property charts and tables. We can see this chart, which consists of absolute temperature, specific heat, enthalpy, entropy, internal energy, pressure, volume. So all these details are provided in the charts. That chart is nothing but thermodynamic property chart. Next topic is availability and irreversibility. Availability is also known as exergy. It's a maximum useful work that can be obtained from a system. Irreversibility is the measure of the work potential that is lost during a process. So these two are very important topics. Thermodynamic relations. Thermodynamic relations are nothing but mathematical equations. So we can see some of the mathematical equations here for internal energy, enthalpy, Helmholtz free energy, Gibbs free energy. Next is applications, that is nothing but thermal engineering. Applications of thermodynamics is also called as thermal engineering. First topic in thermal engineering is power engineering. Power engineering in thermal engineering focuses mainly on the generation and conversion of heat energy into electrical power. So key principles and applications. The core of this process relies on the Rankine cycle, very important. So the examples are fossil fuel power plants, nuclear power plants, solar thermal power plants, combined cycle power plants. Next topic is air and gas compressors. So air and gas compressors are mechanical devices that increase the pressure of a gas by reducing its volume or compressing. So the classification of compressors are positive displacement and dynamic compressors. Positive displacement compressors again classified into reciprocating and rotary. Dynamic compressors are classified into centrifugal compressors and axial compressors. Very important topic. Next topic is vapor and gas power cycles. So vapor and gas power cycles are thermodynamic cycles that convert heat energy into mechanical work, which can be used to generate electricity. So vapor power cycles and gas power cycles are very important. Vapor power cycles like Rankine cycle, gas power cycles like Brayton cycles. Next topic is concepts of regeneration and reheat. So both reheat and regeneration are techniques used to improve the thermal efficiency of power cycles. So reheat is a method where the expansion of steam in a turbine is done in stages. Regeneration is a process that involves using steam extracted from the turbine to preheat the feed water before it enters the boiler. Next topic is IC engines, 8 standard Otto, diesel and dual cycles. 8 standard cycles are idealized thermodynamic cycles used to analyze the performance of internal combustion engines. So Otto cycle is petrol cycle, diesel cycle and dual cycle. Next topic is refrigeration and air conditioning. So refrigeration and air conditioning both work by removing heat from space. Refrigeration is the process of cooling a substance or confined space to a temperature below that of its surroundings. Air conditioning is a process that controls not only the temperature but also the humidity, cleanliness and circulation of air. So the major parts of refrigeration and air conditioning are condenser, compressor, evaporator and expansion valve. Vapor and gas refrigeration and heat pump cycles are here: compressor, condenser, expansion device and evaporator. This is the cycle of heat pump. Next, properties of moist air. So moist air is a mixture of dry air and water vapor. So the study of its properties is called as psychrometry. So key properties of moist air are dry bulb temperature, wet bulb temperature, dew point temperature, relative humidity, humidity ratio, enthalpy. Psychometric chart. It's a graph which illustrates the thermodynamic properties of moist air at a constant pressure, such as dry bulb temperature, wet bulb temperature, relative humidity, enthalpy and moisture content. Very important topic. Next, basic psychrometric processes. So these processes are changes to the state of moist air. These processes are fundamental to understanding and designing HVAC, heating, ventilation and air conditioning systems. So different psychrometric processes like sensible heating and cooling, humidification and dehumidification, combined processes. Next topic is turbomachinery, impulse and reaction principles. So impulse turbine and reaction turbine are very important. These are the two fundamental ways turbomachinery extracts energy from a fluid. So impulse principle involves converting the fluid's pressure energy entirely into kinetic energy. The reaction principle uses a combination of both pressure and kinetic energy to generate work. Next topic is velocity diagrams. These are very important. It is also known as velocity triangle. It's a vector diagram used in turbomachinery to represent the different velocity components of a working fluid. Pelton wheel, Francis and Kaplan turbines. These three turbines are very important. So Pelton wheel is an impulse turbine used for high head, low flow applications. Francis turbine is a reaction turbine used for medium head and medium to high flow applications. The Kaplan turbine is an axial flow reaction turbine designed for low head, high flow applications. Next topic is steam and gas turbines. Steam and gas turbines are both turbomachinery used to convert thermal energy into mechanical work. So steam turbines are external combustion engines that operate on the Rankine cycle. Gas turbines are internal combustion engines that operate on the Brayton cycle. This is the end of this syllabus of thermal engineering or thermodynamics. So all the best for your GATE examination.